Okay, guys, gonna try something new and different for an online day. Have you watch this video and get to the homework. So we're on 3.6 today. However, given that we haven't had math for a block, want you to take out your 3.5 and your 3.6 handouts, and we're gonna review those together. All right. So let me just share my screen with you. Share screen. Here we go. And I will start with a 3.5, collecting like terms. So this is what we did last day. 3x plus 1 equal 41. We're solving for x. Another way of asking you to find the value for that variable x is to say find the root of the equation. Just different language there. So 3x plus 1, because we have plus 1 here, we're allowed to switch teams, change jerseys. So the 1's going to go over, and we're going to be left with 3x equal 41 minus 1. That means 3x equal 40. And then we divide both sides. Divide both sides by 3. You can show it or not show it. For me, at this stage of the game, if you should be comfortable knowing that 3x becomes x by dividing both sides by 3, both sides of the equation. And we're just left with 40 divided by 3 because it doesn't reduce. Okay, that's it. The next one, this, you should picture the invisible 1 under the 9. Okay, it's there. You don't have to write it, but you should be picturing it in your head. Now, if I have that option, there's two methods of completing this type of question. Right off the bat, I see cross multiplication as my way of choice. So 5x times the 1 is 5x because we have fraction equal fraction. We're allowed to cross multiply. And then 9 times 8 is 72. Divide both sides by 5, and I have 72 divided by 5. Done. Can't reduce. Okay. Now, we could throw a wrench in the gears. Some guys always ask, how do you know when you can cross multiply and when you can't? Sometimes the equations get more difficult. So for example, if this question were 5x divided by 8 equal 9, and then it says plus 4/5, well, now you don't have fraction equal fraction, right? You've got fraction equal a constant plus another fraction. And in this case, you have no choice but to multiply everything by the common denominator and get rid of the denominator. But in that case, that's not the question. The question really is 5x over 8 equal 9. And another method, instead of cross multiplying, is the method I just described to you. You could multiply everything by the lowest common denominator. In this case, there's only one fraction, 8. Right? The denominator is 8, the other one is 1. So I'm going to multiply both sides of the equation, or every term, by 8. If I multiply everything by 8, this cross reduces, and I'm left with 5x. And on that side, I'm left with 72. Same thing, right? Same thing as the other method, except I saved myself from drawing all the brackets. If I just cross multiply from the get-go, I don't have to draw brackets and show the cross reducing, but whatever makes you feel warm and fuzzy inside. Remember that? So 5x equals 72, divided by both sides by 5. X is 72 over 5. Again, we covered this before. This was your last day's work. Let's go further here. We're looking for, sorry, this gets a little glitchy sometimes. We're looking for collecting like terms. We can add and subtract like terms. These are some of our learning goals. 5x and 3x are like terms. They both have the exact same variable. So we can add that and say that's really 8x. Okay. 2xy and 2x. The variable here is xy. The variable here is x. They're not the same. One is xy and one is x. You can't add them. Okay. The variable is the letter or letters and their exponents. And you're going to see some more of that below. So here I have ab squared, or 1ab squared. We don't write the 1. And here I have 1a squared b. Because the a is squared in one of the variables and the b is squared for the other one, these are unlike. Now this one's just a bit of a trick. You have ab and ba. Well, a times b is the same thing as b times a. So it really doesn't matter here. I just try to see if you understand that it's the letter or letters. So AB and BA, technically same thing. Proper form is to write it alphabetically, guys, but this is just to trick you a little bit. Okay, so those are like terms. Here I've got p squared q cubed. Here I've got p squared q cubed. Those are like. Okay. X squared, there's that glitchy thing again. X squared and x to the power 4 are unlike, not the same variable. Okay, so remember the variable is the letter or letters and their exponents. They count. We're going to simplify what's below here by simply collecting like terms. I've got a 2x and a positive 3x, and then I have a positive 6 and a positive 2. 2x plus positive 3x is 5x, and 6 plus 2 is 8. Done. Can't go any further. This one's a little bit longer. So collect like terms, 3x squared. Take the sign with you. Don't forget, minus 8x squared. Then I'm going to have minus 5x or negative 5x, positive 5x, and then I've got negative 7 and positive 3. So 3x squared minus 8x squared or plus negative 8x squared. You can add 3x squared plus negative 8x squared is negative 5x squared. 5x, negative 5x, and a positive 5x, that's the zero principle. They just kind of wash out, right? That's 0. So we don't even write 0. Negative 7 plus positive 3 is negative 4. Negative 5x squared minus 4. Done. Some teachers will ask you guys to write that out slowly, like 3x squared minus 8x squared minus 5x plus 5x minus 7 plus 3. You could do that if you like. I don't require that because sometimes you write things too many times and you make a silly mistake, and now you're going to collect like terms improperly. So for me, I don't care about that step. Okay. Now you're going to see this on your upcoming test next week. So please be ready, or maybe end of next week or beginning of the following. So please pay attention because this language is coming up. If you have two polynomials and they're added together, remember, a polynomial could be anything. It could be a monomial, 1 term, binomial, 2 terms, or trinomial, 3 terms. If this polynomial, 2 polynomials are added, so you got this one, whatever it is, plus this one, and the answer is 3x plus y plus 4. Now, they're saying for each statement, well, this is the statement they're talking about. That's the statement, okay? And there's another one below. They're talking about those statements, okay? Is it true that if you add 2 polynomials together and their answer or their sum is 3x plus y plus 4, is it sometimes true, always true, or never true that both are monomials? So what's in there and what's in there both have to be a monomial. Well, think about that for a second. What is this? It's a trinomial. There's 3 terms. Monomials are both single terms. If I have one monomial, for example, like 3x, and another one like y, can you add 2 monomials and end up with 3? Last time I checked, 1 plus 1 is 2, not 3. So that's not possible. In this case, the answer is never true. And it says there in the question, if it's never true, it wants us to provide a counter example. Okay, so let me provide a counter example for this one. Never true. 2 polynomials or 2 monomials cannot, I have this in my answer key on SB, cannot add to a trinomial. Okay, that's not possible. Done. The counter example is like I just showed you. There's a counter example. 3x plus y can equal 3x plus y plus 4. Not possible. Okay. The counter example, sorry, I showed you that already. That should just be written there. Okay, same question, but different statement. If there's an x term in one polynomial, then there must be an x term in the other one. Well, hang on a second here. That's going to be sometimes true, and I'll explain why. The reason why it's sometimes is because it doesn't have to be. It could be, but doesn't have to be. So for example, if I had 3x plus y plus 4. Now we're not dealing with monomials anymore. That was the other statement, right? It just says 2 polynomials are added. So the polynomial could be monomial plus a binomial. It could be a trinomial plus another trinomial. There's a whole slew of different examples we can get here. But if I add those 2 together, look, this guy's got an x term. There's no x term in that polynomial. That's just y plus 4, right? And if I add those 2 together, I'm going to get 3x plus y plus 4. Done. Right? Both doesn't have, you do not have to, it said the must. be an x term in one and then the other. That's not true. So we can have the x term in just one, but you could have it in both. Like for example, I can have 2x in one and a 1x in the other, or I can have 5x plus 3y in this one, and then plus negative 2x, because I know 5x and negative 2x is going to give me the 3x that I need, right? The answer is supposed to be 3x. And then I have 3y here, but the answer has to have just a 1y. So I'm going to minus 2y. I'm going to put the plus 4 there. There you go. I've got x's and y's in both. So in this case, right, that's why it's sometimes true, because you don't have to have x's in both. We could, but we don't have to. Okay. And let's look at the next handout, if you don't mind. 3.6. So let's switch to this. And let me just stop sharing for 1 second. Share the screen. I want to make extra sure that I'm sharing 3.6 with you guys. 3.6. Okay. All right. So these types of questions you should be able to do after what we just did 2 seconds ago. Okay. So you've got two polynomials are added, and the sum is 3x squared plus x plus 4, almost like the last question we just did. State whether the statement is true, sometimes true, or never true. And if it's sometimes or never, you have to give a counterexample. Are they both monomials? Okay, well, again, we cannot have two monomials. This is never true. Well, I should be able to write this in, I think. Make life a little bit easier for myself. Never true. Because two monomials cannot add to a trinomial, right? Two monomials, two single terms can add to three terms. So never true is what we're looking for. The counterexample, again, for example, 3x squared plus x does not equal 3x squared plus x plus 4. Like you just can't, this doesn't make sense. Okay, the counterexample, that is the counterexample. Okay. Because 3, or you could say this, guys, maybe this is better. 3x squared plus x equal 3x squared plus x, not a trinomial. Okay, it's a binomial. Doesn't work. Do both polynomials, if you're adding two polynomials, do both of them have to have an x squared term? Again, that's sometimes true. You don't have to, but you can. So sometimes true. And the counterexample here, right, we can have 3x squared plus x. I think it was a plus 4. Yeah, plus 4. Right? So do they both have an x squared term? I'm just giving you an example where only one has an x squared term, and that's going to come out to that. Again, you can come up with different examples here, right? For a counterexample, I can have I can have 3x squared, keep the x squared term here. I can have plus 7x, right? And the next binomial could be minus 6x plus 4, right? Or 4 minus 6x, whatever you want there. And that answer will still come out to 3x squared plus x plus 4. Same answer. That's what we want, right? I have an x term in both, but I only have an x squared term in one of them. Do I have to? No. So I'm showing that both do not have to have an x squared term. It's sometimes true. And I'm proving that they both don't have to by showing you where only one has. All right. So here we have another. Determine a simplified algebraic expression for the perimeter. I'm just going to tab this down to the next page for my purposes. Okay. Find a simplified algebraic expression for the perimeter. Remember, the perimeter is really 2 times the length plus the length twice and the width twice. So if you add the length and width and then double it, right, that's distributive property, right? 2 times the length plus 2 times the width, right? Or you can just go old school, x plus 5 plus another x plus 5 plus 2x minus 3 plus another 2x minus 3. You could do that. And then collect all your x's, x, another positive x, plus 2x, Then you can collect your other terms. I got +5, +5, -3, -3. And you'll end up with x plus x is 2x, plus 2x is 4x, plus another one is 6x. And then +5 plus 5 is 10, -3 is 7, -3 again is 4. So 6x plus 4. Or you can use this formula here. So I would get perimeter equal 2 times whatever the length plus width is. The length is x plus 5, and the width is 2x minus 3. Bedmass says do brackets first. In the brackets, I can collect like terms. X plus 2x is 3x. And then 5 minus 3 is positive 2. Then distribute 2 times 3x, 6x. 2 times 2, 4. Perimeter is 6x plus 4. You get the same answer. Again, sorry for the chicken scratch, just because I'm writing on the back of a screen, but on Edsby, I have the nice completed versions for you guys, okay? If we're adding polynomials, we remove the brackets and group like terms. I'm going to give you a strategy, guys, that you should use always, okay? Follow this and you'll never make a mistake. You have to imagine that what's happening outside the brackets right there is that there's an invisible positive 1, okay? And you're going to take the sign with you and distribute it. So what I do is drop the brackets here. This is equal to 3a plus 7b, right? The first thing, there's nothing to do here. There's technically an invisible 1 there, and we're distributing it to those and that and that, 3a and 7b. But it doesn't really matter here for the first set. Just drop the first set. But now we're going to have to multiply an invisible positive 1 times 4a, which is positive 4a, an invisible positive 1 times a negative 2b, negative 2b. Because what we're really doing is we're adding 4a and adding negative. When you add negative, it's just minus. Okay, now we collect like terms. 3a and 4a, 7a. Positive 7b minus 2b is just plus 5b. That's the answer. Okay. Subtracting polynomials, that's where the strategy I just taught you a second ago is important. So they're giving you 2 methods. What they're saying here, and I apologize, the next example shows up weird here. Hopefully it doesn't show up like that on your handout. I'll correct that in a second. 3a plus b, and I have this, remember, imagine there's a negative 1 and a 1 there. So this time we're going to take the negative 1 and distribute it. What the question is saying in the learning goals is that if you want, what you could do is just change this to addition and then change the signs in the brackets. So you're going to get 3a plus b plus negative 6a, which is negative 6a, plus negative 2b, which is negative 2b. Now, I'm telling you now, it's easier to pretend for the future because we're going to do other things that are more complicated later. Pretend it's negative 1 times 6a, negative 6a, negative 1 times 2b, negative 2b. You get the same thing, but if you can change your thought process to, let me just distribute a negative, imagine there's an invisible 1 there and distribute it, that's going to make your life easier later. So 3a minus 6a, negative 3a. Positive b minus 2b, well, plus 1b or positive 1b, take away 2 of them is negative 1b. But we don't write the 1, we just write negative b. Remember? That's how you write it. Done. This question here seems to have got glitchy on me. Sorry, so is my screen here. It's got glitchy on me. I don't know, something weird happened there. So I'm going to have to edit that and change it up. That's 3. It should be 3x squared. On my screen, it came out wrong. Oops. So let me erase that for a second. This is just something that happens sometimes when I convert PDFs back and forth. And Word changed their equation editor, so it makes things a little bit harder. All right, let me change this question. It should be 3x squared minus 2x plus 1. And then it's in brackets negative x squared plus 2x minus 5. Okay, that's what it should be. Again, imagine there's a negative 1 here. Oh, sorry, and they're being subtracted. There's a subtraction sign there. Pretend there's an invisible 1. We're going to take that and distribute it to all 3. So I'm going to have 3x squared, just drop the brackets here, minus 2x plus 1. And then we're going to have negative, right? Here we have negative 1 times x squared, negative x squared. Negative 1 times positive 2x, negative 2x. Negative 1 times negative 5, positive 5. Now we collect like terms. 3x squared minus x squared is 2x squared. Negative 2x plus another negative 2x is negative 4x. And then positive 1, positive 5 is plus 6 altogether. That's your answer. Oh, did I make a mistake? Oh, I broke my own rule, guys. See? Good thing I looked back and checked. Negative 1 times a negative x squared is positive x squared. So that should have been 3x squared plus x squared. So it's 4x squared. Maybe some of you caught that. If you did, that's actually fantastic. 4x squared minus 4x plus 6. Sorry. Okay. Whoever caught that, fantastic. If you caught that, you're at home thinking, no, you made a mistake. All right. I got to change this as well. I don't know what happened here. Very weird and glitchy. Strange. And I don't know why. But that should say perimeter equal 7x squared plus 4x plus 2. Okay, 7x squared plus 4x plus 2. All right, so that's what the perimeter is supposed to be. But they only gave us two sides. That means this side here is missing. But we know this plus this, and that's a 3x squared as well. That those two plus the right add up 1, 2, and 3 have to all add together to get 7x squared, right? To get that 7x squared plus 4x plus 2. All right. What do we have so far? Well, let me just collect like terms right in the picture. I've got 2x squared and a 3x squared. So far I have 5x squared. Then I've got this plus x minus 5x. Well, positive 1x minus 5x is negative 4x. And then I've got nothing there, and I got a positive 2 here. Okay. Well, I'm supposed to get 7x squared plus 4x plus 2. But so far I have that. Well, if I'm supposed to have 7x squared, but I only have 5x squared, then I'm going to have to make sure I have 2x squared there, right? Because 5x squared and the 2x squared is going to give me 7x squared if I add that together. I have negative 4x now, right? But it says I'm supposed to have positive 4x. Well, if I'm at negative 4 and I need positive 4, I'm going to have to add, I'm going to have to add 8x, because negative 4x plus 8x, negative 4x plus 4x is 0, right? So negative 4x plus 8x brings me past the 0 to positive 4 territory. So I go from negative 4x to positive 4x. And I already have the 2 that I need, so that's it. So I'm going to end up with positive 4x, positive 4x plus 2, and that's exactly the perimeter. So all we were missing was what's in green here, 2x squared plus 8x. A lot of you guys can do that one mentally, but you do have to show some work for full marks. So just keep that in mind, okay? And that's pretty much it. Look at the handout on EDSB as well. I think I gave you one extra strategy. Take a look at the completed versions there, and we're done for today, guys. Go ahead and do your homework. God bless. Talk soon.